2.10 The Law of Total Probability and Bayes Rule. The problem number is 2.133. A student answers a multiple choice examination question that offers 4 possible answers. Suppose the probability that the student knows the answer to the question is 0.8 and the probability that the student will guess is 0.2. Assume that if the student guesses, the probability of selecting the correct answer is 0.25. The student correctly answers question. If the student correctly answers a question, what is the probability that the student really knew the correct answer? Right. Let me use G for the student guesses. Then C I use student is correct. So what is the point 0.8 now? So you see this, suppose the probability that the student knows the answer to the question is 0.8. So what is the 0.8 then? Yes, the student guesses is G, but student knows the answer is the opposite of the student guesses, right? If student know the answer, then he doesn't guess, he know the answer, right? Otherwise, he guess. We have 2. Therefore, that is G complement. Therefore, probability of G complement is 0.8. And student will guess is 0.2. So, probability of guessing is 0.2. Now, assume that if the student guesses, we know now he guessed the answer, right? So, the probability of selecting the correct answer. Probability of selecting the correct answer, but we know he guessed the answer. Therefore, this condition, it is 0.25. The question is, if the student correctly answers a question, okay, we know he correctly answers a question. So that is the condition with here if, right? So asking the what is the probability that the student really knew the correct answer? That meaning probability student knew the correct answer, right? And also C is the student is correct. That is the given part. So this is probability C and G complement divided by probability of C. Now how do we find the probability of C and G complement? Right. So this I use this one, probability of C given G complement equal probability of C and G complement divided by probability of G complement. From this, probability of C and G complement equal probability of G complement and probability of C given G complement. Okay, understand this one. So then let me explain the next one, probability of C. So probability of C is correct, right? So there are 2 groups, you know that, and guessing and a knowing answer, right? So therefore probability of C equal probability of correct and guessing plus probability of correct and know the answer, right? It means not guessing. So using the same conditional probability equation here, we can write this probability C and G equal probability C given G times probability of G plus next one probability of C given G times G complement times probability of G complement. Now using these two we can write this equation here. Let's say this probability G complement C equal probability of C given G complement. It is probability of G complement times probability of C given G complement and divided by probability of C equal probability of G complement times probability of C given G complement plus probability of G and times probability of C given G. Right, now we know probability of G complement is 0.8. Okay, what is the probability of C given G complement? First understand the G. G is the student guesses. So G complement is the student know the answer, right? Then C is the student is correct. Now think about this. If you know the answer, it means you are not going to guess, right? You know the answer, then what is the probability of give the correct answer, right? It is the 1, right? If you know the answer, definitely then you will pick the correct answer. Therefore, that probability is 1. Similarly, you can fill this one here and plus probability of G equal 0.2 and other probability is 0.25. Then simplify this, you get the 0.9412.